Depends on the teacher, but I'm just trying to prepare you guys. So, today we might have a decent amount of time for homework at the end. This is all guided by you. So we are doing more proofs in geometry, dealing with different polygons. So, your task, if you choose to accept it, which you're here, so you did. For each statement below, construct a convincing argument that is true. Organize each argument into a 2-column proof. So before you dive in, you may want to first just discuss how you're going to get to the end result. But in A, what we're trying to prove is that the diagonals of a rhombus bisect the angles. How can that be proved definitively using math facts we've all agreed on? And then you continue, B and C. Then 47, an idea to explore, a conjecture, which is like something we want to test, right? And then something to prove. Then, if you're nice, I'll give you a theorem graphic organizer that's all filled out. Yes. So really, we have like 4 tasks today. Task A, B, C, and 47. That's it. So I assume that will probably take us like half of class, and then we can dive into practice work. So right now, just with your teams, you're just on your own. Well, come on, and for the sake of time, Levi, I'm going to go ahead and pause the video. We will unpause and keep recording when we actually talk about something useful, but until then, it's just going to be random conversation. Maybe. So everyone probably all dropped an altitude. If we say that's an altitude, it is perpendicular because that's the definition of an altitude. And then if we know that these angles are congruent, then what else can we say? The last angles have to be congruent. Why is that, Hunter? Angle sum theorem, triangle angle sum theorem if we want to be specific. So hyperbola angles have to be congruent. So even without talking about EF and FG yet, I think I heard some people saying H, right? So I've created similar triangles. If I use reflexive property, I can make that congruent to itself. Yeah, but we don't know that it's isosceles. We're trying to prove that it's isosceles, so we can't use that yet. We know. I know that we know, but in this problem, we don't know that until we prove it. So this is where we have to relate the 2 triangles to then justify CPCTC. Angle on the side, right?
That's what we use. Write that out now.
I thought you already like it.
No, I hadn't done that.
No, that was my thing.
Cool down. In the morning, when the heat turns on, it like pours hot lava, and then when things slow down, it cools down.
Okay, so now we're going to do C. Here, I got to look out my book. Let me see which one. Let's go to the diagonal of C. Let's prove that. And we gotta prove that prove that the diagonals of the rectangle are congruent to this one. Which I have no idea how to. There's two. One.
Okay. I wasn't sure if they just wanted like this option. And then you have two times.
So our last one should be line IJ. IJ is congruent to HK.
What? Why'd you split it up into four? Four triangles.
I didn't. We have to prove that these two sub HJ. We have to prove that HJ is congruent to IJ.
Oh,
No, diagonals are different. No, not that one. I'm still finishing.
I code 12.
You prove that the triangles are congruent.
for what?
I'm missing AO. I have a band thing to do. Wait, Lauren.
Yeah.
Call time for the band thing is 12:15, right?
Yeah.
Because then you
Okay. And we'll be missing lunch.
No, we don't miss lunch.
I mean,
We eat
we're
lunch
missing
and we
A.
have
We're missing
leftovers.
AO.
Yeah.
We could have missed reading. For the band thing.
What time do we go to bed?
Oh my gosh.
Wait, what do you mean by
We missed like 90% of the foundation.
Because so like what? Right now we have reading in the morning and then instead later we'll just do
Well, yesterday in this foundation
That's not
study,
bad. You
we
still
did all
have
the
to say
salaries
No, you
for
don't.
the day.
Oh, you don't?
Yeah, because you have
That's
reading
your
every day and AO every other day.
I don't know what salary I have.
Yeah, I know.
I just thought you guys changed it.
Yeah, we did
I
change
got
it.
20,000
All hard work.
and
You don't have to pay.
I mean, it stayed for like June.
I really don't want a big one.
Oh, I didn't know. It's like
Oh, I
reading
Just
every
for
day.
documents.
Yeah.
I think you should back.
Are we talking about
Dude, all this got again this week.
So in the diagonals of a rectangle one, which I think a lot of us are onto, we know that a rectangle has those right angles to start. We know that a rectangle is a parallelogram. We know that a rectangle is a congruent side shape.
I have no idea how to solve that one.
Sometimes it's helpful to do like two different things. So if I copy this twice, Levi just had like a few minutes of nothing or whatever you guys were doing. So I left the recording on. If he watches.
If.
That's a
So if I draw the two, huh?
Need word.
Maybe.
The word is maybe, Levi.
No, maybe there's a code.
Okay, maybe is the code.
We don't know yet. We don't know.
Maybe.
Fine, we don't know.
So I draw that diagonal
Maybe.
and this diagonal. We've already defined
Oh, they're just reflections.
Yeah, are we trying to prove that there's like
Diagonal.
We're just
you are proving the diagonals are congruent.
So AIJ equals HK.
You do side angle side.
Wait, no, not IJ. IK equals
Look,
HJ.
look, HKJ is a right angle. We know that from the definition of a rectangle. So you can do side angle side.
easy peasy?
Then once we have side angle side, CPCTC.
Easy peasy.
What is CP?
What does that stand for again?
Congruent, or sorry, corresponding parts of congruent triangles are congruent.
Oh,
So,
okay. I have a
corresponding
definition of
Parts, or some people like to say pieces, corresponding parts of congruent triangles. I don't know why I just squiggled that. Because I'm thinking congruent in my head. Are congruent. So matching
Weird fuck that.
pieces of same size. I'm trying to think of a synonym for triangle. Trigon are congruent. Trigon. It's a trigon. And the last one here. Now these are the fun ones. Well, fun being relative. But when we extend out above, what does extending these auxiliary lines do for us?
Makes
Make
it
it
into a
trapezoid.
triangle that we can then tell is like the thing of a thing.
It makes our trapezoid into a triangle, right?
And we
As
can-
soon as you said
oh.
thingamathing, I'm going to talk over you.
Okay.
So if you want to use real words, I would like to give you the floor.
So once it's a triangle, you can just do the same thing you did for B.
So what is that thing? Walk me through it.
Well, so you can draw another line down through the middle from
Okay.
A to the midsection of HG.
Now wait. We proved isosceles triangles, right? We proved
Yeah.
the converse of what we already proved. So what we had proved was if a triangle is isosceles, it has congruent base angles. What we now proved is the opposite. If a triangle has congruent base angles, it must be isosceles. And under that premise, we know and we have proven previously that then means this whole thing is congruent to that whole thing. Right? All of that, because we've already proven it, we can state in here, we can cite it.
Which means that EJ is equal to JF. Because EF is a straight line, which is in trapezoid. Because EF and HG have to be parallel.
Okay, so EF and H here are parallel, that's given to us.
And then the straight line of an EF is a straight line.
And I have no opposition to drop an altitude if we want to. If you had said that, we
Well,
could.
then now we just got the same thing with EJ whatever and J whatever.
HG is congruent to G. HJ is congruent to
So then we know that EJ is JF. Yeah, EAJ is congruent to JAF because we just did that with the other thing.
Mhm.
And then so that we know. And then we know that yeah, EJ is congruent to JF. So subtracting JE from HE from HJ will give you HE, which would be the same as GF.
You said G a lot.
Yes, I did. And actually, mostly I was saying E. If you'll notice, Satya.
Yeah, it sounds like a foreign language if you don't know what it means.
Sounds like Arabic. With like
So wait, what's our conjecture? What are you thinking we're trying to prove here?
That a trapezoid is congruent base angles that is isosceles.
Which means,
Yes, there's such thing as an
isosceles trapezoid.
yes, there absolutely is such thing as an isosceles trapezoid. So, here's my challenge, and I'm going to release you guys to work on homework for like the next 12 minutes, whatever.
No, don't kill us.
My challenge, yeah, whatever even show that is there a converse to what we proved, and can that be proven? And the converse always takes the if and the then and flips them. Is there a converse to the rectangle theorem that we did, and is there a converse to our trapezoid theorem that we did? If you are interested in those, I encourage you to explore those thoughts. Otherwise, we can just work on practice and continue solidifying our knowledge base.
Some homework?
Now, I know I didn't have you guys show your work because I realize sometimes people just really aren't down with that. I had the answers open, but apparently not now.
So we did that to make it
Yeah, but it made you work better.
No, it didn't.
I've already gotten 4 questions done though.
So if you want what the book did for these proofs, here's that.
Can we come up and show ours?
Yeah, I will totally put it up here. I just didn't want to force anybody. So we can compare it too. We can put yours like up on the, actually we can put theirs up on the TV. I wonder if anyone nailed it, like every step in the same order.
Pretty close, but no.
Let's go, presenter, let's go.
I forgot to put reflexive. Shoot, hold on, let me just like.
Where? On A?
Yeah, on A. We have to put a map really quick.
You guys ever find gradient color interesting?
What gradient color?
This is black. All of this is black.
That's not black.
Yeah, it is. It's black. This is black.
That's white.
You're right, because it's gradient because of light.
What does gradient mean?
It changes, like gradual change. Like, so if you go into like paint or whatever, you can change the tint, kind of the gradient shade of the color.
Oh.
It's like going through the like dark to light
So
scale.
like, did he make it like really white? So
This is black. It's just the light. It's how the light is hitting it. Like, it's just so interesting how the camera perceives the color versus what the color actually is.
What if the camera's right and we're wrong?
What if, Satya? What if? All right, so here is Chris's that he wanted to show.
Oh, that's cool. The way you wrote it, it's like going along the side of it.
What is IBA?
Isosceles basic.
Okay, so don't do that on the ACT or SAT.
Okay.
Like, you will not get points for that.
Okay, so don't do that.
Don't do that. And then part B.
Oh, yeah.
I've had a question like that for so long. People can change their gender. Can I change my age?
No, because your age is a mathematical fact based on time, which is a fixed concept.
Oh, but
Nope.
Here's the thing, it's a human concept. I'm human. I
I
can
can
change
describe
my
my facts
concept.
and logic.
Oh, you can change how you can call a year a klaxon if you want, but it doesn't change that a year of time is a year of time.
Well, here's yeah.
There's his B. If anyone wants comparison. So
Wow, that's wow.
the first thing they do in their B is say like, here's what I did. I did a auxiliary line. Right? I'm gonna try to squeeze things. I can't click. Then they show congruent angles, which was the given definition of a bisector. This is reflexive. They just don't say it. And we can use angle side, which you did.
It told you. It says you have to graph it.
Pretty much the same thing.
Yeah. It works.
Yeah, like actually.
I did do the same thing.
Yeah.
Make up the graph.
All right, that's all we got. Levi, code words maybe.
Maybe it is, maybe this